Hello and welcome to the Alan I. Carswell Observatory Astronomer in Residence program special presentation. This is the Alan I. Carswell Observatory Astronomer in Residence with Killarney Provincial Park for 2025. Tonight we have a special presentation direct from the parks. We're joined by two astronomer in residences for, of course, this July 17th, 2025. On site out at Killarney Provincial Park in Ontario, Canada, every summer, we run astronomer in residence programs out there for the public to enjoy the wonderful, beautiful dark skies and, of course, a bit of nature as well. I'm joined tonight by Anna and Sana, who are our astronomer in residences this week. Sana, are you there?
Yes, we're here. Hello.
Exposure
And
started.
that must be Anna as well.
Yep.
Wonderful. We're going to pass it over to you folks. And can you tell us what telescope you're using tonight?
Yes, we're using the 16-inch telescope. Right now, let me share screen so you can see what we're seeing.
Exposure finished.
But we are using the 16-inch
Exposure started.
telescope. Can you see the screen?
We can. It
Ah,
looks amazing and a little bit familiar.
Yes. So this is a familiar object called Messier 16, also known as the Pillars of Creation. This nebula was made famous by the Hubble Space Telescope quite a while ago because of the spectacular image that Hubble took of the Pillars of Creation. Hubble was only able to see this tiny part of the nebula here. Very similar if you've seen the image from the James Webb Space Telescope. It just kind of looks at a portion of the nebula here. But like all nebulae in the Milky Way galaxy, these are actually really massive clouds of gas that are currently forming stars. So what we're seeing here with the 16-inch is a much wider area of the sky. So we're able to see a whole lot of different parts of the nebula, not just the pillars themselves, which are over here.
Exposure finished.
So the pillars of creation are, like I said, it's a star forming region. So all of this area, all of the detail that you see in the image is gas in the nebula, and then there are stars embedded within it that are forming. In each of the sort of peaks of the pillar, they kind of look like fingers almost. In each one of these little pillars or fingers, what will be happening in there is a whole lot of star formation where there's a bunch of young stars that have just been born out of that gas and are in the process of sort of clearing away that gas through their light and through also from stellar winds and when they're ejecting material off of the surface. So the image that we're seeing here of the pillars of creation is going to be very different from what somebody a few thousand years from now would see, when all of this material will have basically been cleared away or messed up a little bit, so they won't actually look the same or last too long.
Yeah, and it's really interesting, just as a little call out, what we're seeing here as we're taking images is the result of several seconds of light being collected, which people sometimes don't realize because our computer is doing it for us very sneakily behind the scenes here. But if you could hold your eye open for longer than just its usual nanoseconds of light collection, you might be able to build up pretty images like this. So what's your exposure time right now?
We're currently on 15-second exposure time.
So that's 15 seconds. That's pretty darn good for the image that you're getting here. And just in case people in the live stream are wondering, the audio you're hearing in the background is from the computer keeping track of the exposures as we continue to build up. And each one of these that's shown here in the live image is one of those exposures. What we can do later on, of course, is stack them and make even clearer and more accurate astrophotography images out of them later, maybe tomorrow.
Yeah, we'll definitely be downloading this data quickly and trying to make some pretty pictures out of it. So yeah, those will be coming very soon.
And since you are out on site at Killarney Park, I will just say that for anyone in Ontario or the general Northern Hemisphere, if you're interested in M16 and you are in a very wonderful dark sky site, it is just above Sagittarius tonight, so it makes it kind of an easy thing to spot
Exposure
if you're
finished.
out naked eye,
Just passed
looking
through meridian.
sort of towards the
Failure started.
south-ish. And up from Sagittarius. You won't be able to see it, but you will be able to see some of the nearby stars that are in the region.
Exposure finished.
Yes. Sorry, the software is very talkative
Exposure
tonight.
started.
But yes, there's a whole lot of really interesting material in the Milky Way. It's really remarkable how well you can see it from Killarney. You can see a whole lot of really interesting kind of detail around in that Sagittarius area, a whole lot of stars. So it's really a beautiful sight, even without a telescope.
Yeah, and this kind of area is also a great spot for Messier objects. There's much more than just M16 in the area. I think I would have trouble even counting them all. I know M17 isn't that far away, and M24 is also pretty close by, I think.
Exposure started.
Yes. Yeah. There's a lot of globular clusters in the area as well. So sort of the very dense collections of stars. So you wouldn't see any of the gas detail, but just a whole whack of stars. There's quite a few of those in the area, including Messier 4.
Yeah, so we're at still on M16. Do you think you want to try to go to another object for this evening?
Yeah, definitely.
Exposure.
All right, well, let's
Right.
see if we can get there. And while we're on our way, I might just talk a little more about the interesting M16 area. I think, it does have, as you mentioned, it's kind of got a lot of names. The Hubble image made it pretty popular with the pillars of creation, but it has been called so many things by so many different people over the years. It's got great history, shall you say. It's actually just in the constellation Serpent, and it's been called the Star Queen Nebula or the Eagle Nebula M16, of course, from the Messier catalog. Who, of course, Charles Messier famously was not looking for these objects. He was looking for comets and made a list of things that were not noisy things that shouldn't belong there, like this one. So the Eagle Nebula is in the Sagittarius arm of the Milky Way galaxy and is a very, very young area. So it's, on the grand scheme of stars and gas and dust, it's only a couple million years. So you think maybe only 1 or 2 million years old, which means these stars have just barely begun to figure out their lifetimes. They have a lot of really bright stars, which don't live very long because, of course, the area is very, very young. And those bright stars in particular, I think there's the brightest star in the cluster around the Eagle Nebula is something like an apparent magnitude of +8, which means you'll need binoculars to see it. And of course, if you have a telescope, you can see all the cool gas and dust like we're seeing with that image from you guys.
Oh,
now we've moved over to sorry, I lost track. 17?
20. This is the Trifid Nebula.
20. We moved over to M20. Yeah, so talking of gas and dust, boy. This one is maybe even more spectacular because it takes up a smaller region of the screen. It's kind of obvious where it is.
Yeah, we're actually switched to the different telescope. There's the smaller 5-inch refractor on the top. We're using the software.
Yeah, that field of view is going to be way bigger on that.
Yeah, we're planning to switch back to the 16-inch telescope in a second, but it's just plate solving for us right now, so it's making sure that we're pointing very, very accurately. So the software actually just made that small adjustment that it did just there on its own. And if you give us a second, we will switch back to the other camera once it's done plate solving.
Yes, and I probably should mention as well that if folks are interested in sort of the list of cameras and telescopes out at Killarney Provincial Park as part of the observatory.
Exposure
Most of
started.
them are listed on the Astronomer in Residence page, and it's quite a flock, actually. In addition to the two domes, we have a whole bunch of fun stuff out there, and lots of great things to read about if you're interested in sort of gathering information about different types of cameras. And I think all the manuals are still listed on the website as well. So just in case anybody wants to follow along, it's on the Alan I. Carswell Observatory website, yorku.ca/science/observatory, and then you just go to /air. You will find as well an air blog tab where anyone who wants to can follow along with Senna and Anna's blog, as well as everyone else who's gone this year so far in the last couple of years. Who knows, maybe one of these pictures might even make it into the blog at some point, which would be pretty fun.
Yeah,
Exposure finished.
we will definitely be putting some of these images in the blog. We've switched over to a different camera, so we just brought the exposure time down a little bit so that we can get a better idea of we don't overexpose the camera or let too much light into it, but we're just going to increase this exposure time so we can try and see a bit more detail. I can already see a little bit of detail right here. There was that kind of blue and that red sort of circle in the nebula. I think I can see some of the red one. Oh, there it is.
Very nice, very nice. And we will say, just as a comparison, of course, the Killarney telescopes and the one you're using are quite a bit smaller in diameter than the one we have at York University, especially the 1 meter telescope. But your skies are so much better. It really, really helps to bring out these nebula and gassy structures, especially things like, of course, M20 and M16, which have extended faint gassy regions. Those are exactly the kinds of features that tend to get wiped out completely by light pollution, which we have so much of it here at York. And when it's clear, very, very little of out at Killarney Park. I believe it was a Bortle class 2, if I'm recalling, was the last classification.
Yes, Bortle 2.
Almost as good as it gets.
Exposure started.
Yes.
Exposure canceled.
And you were actually saying before we started about the Milky Way being incredibly bright tonight.
Yes, it is. I was commenting that even staring at the screen. What is it? What is it saying?
Here we go.
Oh, sorry.
Yeah, no, this is great. We're watching in live action as the menus get adjusted here.
Yeah.
And right. This is truly live, everyone.
Yeah, I was saying earlier that even sitting here staring at a computer screen to set up the sequences and set up the imaging, even when I just look up out of the dome, I can still see the Milky Way after looking at the screen. So my eyes are really not very well dark adapted. Typically, you'd want to not look at screens for something like 15 to 30 minutes before being able to actually have fully dark adapted eyes. But even just looking at the screen, the Milky Way is so bright here that I can still see it without fully dark adapted eyes.
Yeah, and it's the trick, of course, is that the Milky Way has not changed in brightness. What has happened is, of course, the sky itself has gotten much, much, much darker because it's not washed out by all the light pollution from a bazillion tall buildings.
Exposure finished.
But this is looking really, really excellent. I can see you've increased the exposure time. How far up did you go?
This is still at 15 seconds.
Oh, 15. That's wonderful.
Yeah. Yeah, I think the smaller telescope was using some longer exposure times, which is why the nebula looked a little bit different when we were imaging it with the other camera. But this time we're getting a bit more of a zoomed in view, and when we take all the images and stack them, we should be able to see the blue part of the nebula over here really well.
Yeah, and I honestly think both views are really wonderful in very different ways. Of course, having the wide view, it's almost like we've gone with our spaceship telescope closer to the into the nebula. So it does really feel like space travel when we do it this way.
Yeah. it's a lot of fun to also think that we're looking into the past when we're seeing these objects. So much like with Messier 16, the Pillars of Creation that we were on last, this nebula is going to change over time because of the light and the stellar winds coming out of the stars. So we're not actually seeing the nebula the way it looks right now. We're seeing the nebula as it was probably a few hundred years ago when this light was actually emitted. I believe it's about a few hundred to maybe 1,000 or so light years away. So in reality, if we could take a real spaceship and go there right now, it would look completely different.
So yeah, you're looking at about I think 4,100 light years.
Okay, that's further away than I had thought, but yes, we'd be seeing it thousands of years in the past.
Exposure finished.
I think. I have to quantify that because I'm not quite sure of my source on this one. But yes, it's one of the great things about these nebula as well is they are in motion, they're in progress, and so even though we're seeing them as they were, hundreds or thousands of years ago, we can still watch them change, and so year to year, over the course of 2, 3, 5, 10 human years here on Earth, we can watch these nebula measure the gas and actually see them change over time. So we're seeing them change as they changed that many years ago, but we still get to see the motion, which is really, really cool and unusual, because for, of course, a long time, large parts of humanity thought that the heavens should be unchanging.
Exposure finished.
Yeah, it's really remarkable, even just thinking about timescales in astronomy. Short-lived stars still have lifetimes of hundreds of millions of years. So the fact that we can actually see on such very, very short timescales the changes in these nebula is really amazing.
Yeah, and the Trifid Nebula is also, I guess, a great follow-up to our previous one because it was also imaged by the Hubble Space Telescope. And it's also a stellar nursery, but it's a very different kind of looking nebula. It has very different structure, and it does seem to have kind of a very, very large central stellar jet coming out of it. So it's got some kind of really interesting things happening. And stellar evolution is incredibly dynamic. So in this case, you could almost, I mean, we can't sit here long enough to watch it move, but if you could take pictures of this over the next couple hundred years, you would definitely see changes in the structure.
Yes, even in some not star forming regions, but dying stars, even over the course of a year or two, you can sometimes see some of the material expanding after it was ejected out into space. And you can kind of see over even a couple of years, sometimes that material moving around, which can be a lot of fun.
Oh yeah, it's we can't get enough of looking at beautiful stars and gas, of course.
Yes.
And it's this one is a really peculiar object, which means it's really a lot of fun to look at by pretty much everyone. So of course, amateurs can spot this one reasonably easily with small telescopes, and it is still actively investigated by astronomers and professionals because of its unusual appearance. And it does seem to have, sort of almost a 3-lobe structure. I think it's the dry part of the Trifid. And it's got an extremely massive star in there, about 20 times the mass of our sun. So there's a lot of, again, really, really young stars that are not going to live that long, creating immense amounts of energy and injecting that into the gas, speeding it up and helping to create these really interesting structures.
Yeah, stellar births and stellar deaths are really amazing to be able to see. They're just, everything is so pretty.
Absolutely. Now let's see here. Do you guys think you have time to get to another object tonight?
Yeah, I think the other object we were planning on was Messier 17. So let me just stop this. We'll have to switch back to the other camera for a second. Let me just get a bit of light.
USB device disconnected.
And I'll just go ahead and let everyone know that all of these objects that
USB
we're
device
looking at
connected.
tonight are in the same part of the sky, sort of just above Sagittarius and well, in the northern hemisphere right now, I should say, because of course, if you go to other places on Earth, it might look different oriented. Um, and they're all really, really interesting star fields in various ways. Now, if you wanted to actually go from place to place with a telescope, one of the great things you can try is to hit several objects that are in the same region of the sky. And that way you don't have to wait for your telescope to slew all the way across and potentially get lost or something, depending on
Synchronized to the given
the size of the
coordinates.
telescope and how well calibrated it is. So this is another really fun one, and it's for going for lots and lots of interesting things. I think the Omega Nebula is a great follow-up. So M17, like our other Messier objects, has been called many things by many people. This M17 has been
started.
called um, the Swan Nebula, Checkmark Nebula, Lobster Nebula, Horseshoe Nebula, and of course M17. And it even has an NGC number. So this one's a little bit farther away. It's between 5 and 6,000 light years away from Earth. So its light would have taken even longer to reach us. And it is a cloud of interstellar matter, which has gotten some very interesting properties. It's one of the brightest and most massive star-forming regions. And it's actually got some similarities to the Orion Nebula, which is a little harder to get to this time of year. So if you're looking for geometry similar to the Orion Nebula and want a cool star-forming region, the Omega Nebula is not a bad thing to try to get to next. Its apparent dimensions, if you're using your sort of angle measurements on the sky, is 11 arc minutes. And so this is also something that you need to have a small telescope to be able to see. Its apparent magnitude is 6th magnitude. So under extremely dark skies like those at Killarney, if you are really well trained, you might just barely be able to see something.
USB device
Maybe.
disconnected.
But it would be just the haziest, faintest thing. So it's definitely recommended to have binoculars or really a small telescope if you want to try to tease out anything for these nebula. The problem with nebula in observing them is that because they're diffuse objects, they're actually really hard to see. So if you have just an ordinary telescope with an eyepiece that doesn't have a cool camera like what we're seeing here at Killarney Park, it can be really, really hard to see. It'll be much fainter. It'll be in black and white, and you might have to do what's called averted vision. So if you're trying to find some of these nebula objects with your own telescope or binoculars, and you just can't get to it, but you know you're pointed in the right place because you've checked the coordinates, what you do is you don't try to look directly at it. You sort of look off to one side, look off to the other, and averted vision plus making sure you're really well dark adapted can sometimes bring really faint objects into view if you're going with an eyepiece view rather than a camera view. Camera views will get you the much more spectacular features though. So if you're, and of course, astrophotography. They both have benefits and downsides. But yeah, the Omega Nebula is a really interesting one, and it's absolutely massive. We talk about things in space with light years because, of course, they're so gigantic, it's hard to measure otherwise. It's worth remembering that in our own solar system, light still does take time to travel places. It takes about a second to get to the moon. It takes about 8 minutes for light to get to the sun from Earth. And if you're on Earth, light is so fast, it seems instantaneous to us. because Earth is really, really, really small compared to outer space. So if you want to get a little bit of a scale bar, if you have something traveling that seems
Exposure finished.
instantaneous on Earth, and it seems to take 8 minutes to get from Earth to the
Exposure
sun,
started.
well, the Omega Nebula would be 5,000 to 6,000 light years away. So it kind of gives you a little bit of a hint about how much more distant these things are. The Omega Nebula is also big in addition to being far, far away.
Exposure finished.
It's about, I think, 40 light years in diameter.
Exposure started.
So it would actually take 40 years for light to travel from one side of this nebula that you're seeing just to the other side of this nebula. Um, that's how big it is in space. It gets ridiculous to talk about the size of things in astronomy, but there you go.
Yeah, so this is the more zoomed in version
Exposure
of
started.
Messier 17. The fun thing is I remember imaging this nebula with the 1 meter telescope, and the 1 meter did a great job, but you can really notice the difference with the light pollution
Oh
around
yeah.
here because you're able to see a lot of this very faint gas. The 1 meter really did a great job kind of in
Exposure
this
finished.
brighter area of the nebula itself, but I don't think it was able to pick up on a lot
Exposure
of the
started.
surrounding stuff just because it's so bright at York University. So it just kind of gets outshined or outshone by a lot
Yeah,
of the other light around.
exactly. It's the diffuse outer structure is the first thing you lose with light pollution.
Mhm.
Exposure finished.
Yeah. One of the other interesting thing I might want to point out
Exposure
is
started.
you kind of see there are some areas that look very dark in a lot of some of these nebulae. I think there were a few areas in Messier 16 as well. And one of the cool things about those areas is that they actually are dark, not because there's nothing there, but because there's just way too much stuff there. There's a couple stars, if you look a little bit closely, that look kind of
Exposure finished.
orange or red. And that's actually because it's a very dense cloud of gas
Exposure
in this
started.
area, and these stars are embedded within that gas. So we're not actually seeing the stars in their actual color. We're seeing them as reddened after their light had to pass through all of this gas and dust to reach us. So it's kind of a fun thing of in nebulae, the dark regions are not actually empty. They're just
Exposure
too full of
finished.
stuff.
Yes, and of course, if we go into infrared, like James Webb Space Telescope, then you get to see more of that detail because, of course, the light can pass through that dust.
Yep. So you're kind of starting to see a lot of the baby stars that are forming in these regions that we can't see with visible light.
Exposure finished.
Yeah, exactly. So what we're seeing right now is just the
Exposure
outer
started.
shell, if you will, of what has been illuminated by the light that has managed to escape.
Yeah.
And much like our other star-forming objects, for star-forming regions, I should say, this one also has a lot of very bright,
Exposure
hot,
finished.
young stars. And the number of
Exposure
stars
started.
in this particular nebula seems to be quite high as well. So despite the fact that it has a lot of gas, it also has a lot of stars in it, and I think they measured something like um over
Exposure
a
finished.
thousand or something of stars that they'd actually managed to find
Exposure
in
started.
the nebula so far. Um,
Wow.
and the age is actually, I think, the youngest that we've seen in the live stream tonight. It's just they think just under 1 million years. So basically a baby.
Yeah. By stellar terms, basically a baby.
Basically.
Exposure finished.
And it looks
Exposure
fabulous as
started.
well.
Yes. Yeah, this is a really great, like you were mentioning, this is a really great region to stargaze, even if you don't have big telescopes like the ones out at Killarney. If you even just have a small telescope or a pair of binoculars, you can really just kind of scan around this area in the galaxy because there's so many stars, there's
Exposure
so many
finished.
regions like this that if you are under dark enough skies, you can
Exposure
see very
started.
well even without a large telescope.
Yeah. And if you want to know why it's called the Omega Nebula, you'll actually have to go way, way back in history and get a very much smaller telescope than what Sun is using and a photographic plate. Because the first images of this back in the
Exposure finished.
1800s, there's a wonderful drawing by John
Exposure
Herschel
started.
that shows this nebula, and he was drawing it from what he could see through the eyepiece using averted vision tricks and whatever else he could. And on a very, very wide field view, he was just able to make out a shape that looked a little bit like the
Exposure
omega
finished.
symbol. But we don't
Exposure
really see
started.
that here because we're doing too good of a job with our image.
Yeah, I remember reading a similar story about the wild duck cluster, which is another cluster you could see with binoculars pretty easily. It has a whole lot of young and bright stars, and the brightest stars in this cluster form a kind of V shape
Finished.
when you look at it with telescopes that are not as good as the ones we have today. So
Exposure
it's
started.
similar to the V kind of formation that birds make when they fly, hence the name the wild duck cluster. But really not something you can actually see if you use modern telescopes.
Yeah, absolutely. Well, this has been a really wonderful, wonderful fun time tonight, Sana and Anna. Thank you so much for
Exposure
setting this up
finished.
for us. And just as a little bit of
Exposure
a round
started.
off, I suppose, for the evening, do you have any tips that you might give to future astronomers who want to come out to Killarney Provincial Park and participate?
Uh, like people coming for astronomer in residence or just coming to stargazing?
Oh, just either one.
Either one. Use stellarium is a very good tip. We were using stellarium to plan a lot of the observations, so you can kind of see what's going to be up at what time of year if you're coming out to observe, and also just bring a sleeping bag or a chair or something so you can sit back and actually stare at the sky. Last year, Anna and I did not bring any sort of beach towels or sleeping bags, and our necks were starting to hurt staring up at the sky for so long. So
Oh my
bring
goodness.
those and just sit back and enjoy the sky.
Absolutely. And I will totally second your Stellarium recommendation. And actually, just so folks know, there's a free website that also works on your phone browsers as well, stellarium-web.org. It's totally free. So just make sure you set your location to the correct place on Earth. And you'll be able to get the constellations and all kinds of good coordinates for pointing telescopes and everything else.
Yeah. We are also approaching, I feel like I should probably mention this, we're approaching the peak of the Perseid meteor shower. So the peak isn't until early next month, I believe, but we're getting close enough to the peak that you can actually observe it. The moon is not up until later in the night for the next few days. So that's a great time to go out and see if you can spot any meteors. I actually saw one meteor while we were setting up, and I wasn't looking directly in the direction you should be looking for the Perseid meteor shower. But if anyone is out stargazing, especially under very dark skies in the next few days, this is a good time to keep an eye out for some of the Perseid meteor shower.
Oh yes, absolutely. And of course, this time of year when the nights are somewhat shorter, we need to get as much astronomy in as we can every evening. So it's
Yeah.
a wonderful tip. And I'll just go ahead and give one final tip since we're talking about stargazing to round off our show. There is a lunar occultation on July 20th. Which is the moon passing in front of the Pleiades star cluster. So anyone in North America, which includes Canada, should be able to see part of it at least on July 20th, which is in just a couple days. So the Pleiades will be quite close to a crescent moon, I think. Or wait, waning crescent moon? Yes, waning crescent moon. So feel free to enjoy all the star views you can, and hopefully this has been a fun event for everybody to tag in with Killarney. I know that I am
Exposure finished.
super jealous of your dark skies, Sana and Anna.
Exposure started.
It's been really nice to be back here and actually see so many constellations and so many stars out. I know it gets very hard from where we live to even go out on a clear night and be able to recognize a lot of constellations. But from here, it takes a little bit of work because there are so many stars. It can be a little bit hard to see the constellations, but I can actually make out the fainter stars in a lot of constellations now. So it's fun to kind of go around star hopping and just seeing what's up in the sky.
Absolutely. All right. Well, that's it for us tonight, folks. And thanks, everyone. You have been listening to the Alan I. Carswell Observatory special broadcast from the Killarney Provincial Parks Astronomer in Residence Program 2025. We've been joined tonight by Sana Withers and Anna Skrinick operating the telescopes out at the observatory at Killarney Provincial Park in Ontario, Canada, as part of the Alan I. Carswell Observatory Astronomer in Residence Program. If you'd like to find out more about the program, our free shows in Toronto, or anything else, you can always see at the website yorku.ca/science/observatory. Thanks for tuning in, everyone. Have a great night, and don't